Let's go through these questions together. You can pause to read the first question. Being about an arithmetic sequence, I brought here in the formula from the formula booklet. An arithmetic sequence has 12 as its first term, so U1 is 12. And the common difference of negative 5, so D is negative 5. Find the 12th term. That would be a formula giving me the nth term, so the 12th term is U12 equals U1 plus n minus 1 times D, which I can put in my GDC. And I get negative 43. Question 2. It's again about an arithmetic sequence, so I open the formula booklet to see those two formulae. The 14th term is 100, meaning that U14 is 100. First term is 9. U1 is 9. Find the common difference. Now, as you see here, that's a formula linking the nth term. So in my case, U14 is U1 plus 13D. So in this equation, I know U14, I know U1, and I need to find D. So I can use nsolve in my GDC, and that's what I'm going to type. And my GDC will give me D as being 7. Question 3, it's again about an arithmetic sequence. So if we look in our formula booklet and we map the information given into equations, we know that the fourth term is 5, while the sum of the first 6 terms is 10. Sum of the first 6 terms is denoted by S6, so S6 is 10. I must to find S19. I need to refer back to the two formulae in my formula booklet. And U4, which is 5, will be U1 plus n minus 1, 3D. S6, which formula shall I use now? That one or that one? In this formula, in the first formula, I see the number of terms, the first term, and the common difference. The second one is an equivalent formula where I see the number of terms, the first term, and the last term. I don't know the last term, but because the first equation is with the first term and common difference, I'm going to use that formula. So I will write S6, which is 10, equals 6 over 2 times 2 times U1 plus n minus 1 D. In this case, n will be 6. What I see here are two equations with two unknowns, and they are linear equations. So we can use either in your GDC lin solve or use an algebraic approach of GCSE type. I'm going to use lin solve. So in my GCSE, I use from algebra, I choose numerical solve, two equations. I can even call them U and D. And now I type the two equations exactly under two equations here with the unknowns U and D. Six over 2 is 3. Enter. And here are my answers. Therefore, my answers are U1 equals negative 15, D common difference equals 20 over 3. As a reflection on those three questions, the important bit is to map the information given into equations. Once I have the equations, I look in my formula booklet and I replace the number I have in those equations, obtaining either one equation or simultaneous equations that I then solve using my GDC. I'm going to start by explaining what the sigma symbol means. In this question, you can directly use GDC, but I'm going to show later how the GDC calculates this sum. Let's just look for our own understanding what this sigma means. Sigma stands for sum. And if I'm looking at 2i minus 5, which is a general term, if I first replace I by 3, I get 2 times 3 minus 5, which is 1. If I replace I by 4, I get 2 times 4 minus 5, which is 3. I equals 5, so I get 2 times 5, 10, minus 5 is 5. Up to the very last term, which is for I equals 100, which I see it up here, and I get 2 times 100 minus 5 is 195. Sigma symbol means that I add all those numbers. So my result will be 1 plus 3 plus 5 plus dots, 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 dots until 195. I could find this sum by using the formula for the sum of an arithmetic sequence, because these terms are in an arithmetic sequence. So this question could be asked in a different context, but for now, I am just asked to find this sum. So as I have GDC, I can find it very efficiently using GDC. Under the toolbox, you have the sigma symbol. And now we just copied I from 3 to 100 at the expression 2i minus 5. So this is my answer. If you add all these numbers, you can use a spreadsheet or you can use a formula for the sum of an arithmetic terms of an arithmetic sequence. You should get this number. It is enough in your exam paper if you just write this answer and you write by GDC. You don't need to write all this working, which we've done here just to recall what the sigma symbol means. And here we start question number 5, which is about geometric sequence. So I brought here the formulae that we have about geometric sequence. So we know how to find the nth term, and we know how to find the sum of the first n terms using a formula. Let me now map the information given into equations. Fifth term is 3. So U5 is 3. Seventh term is 0.75. So U7 is 0.75. Find the first term and the common difference. Let's put this equation into in terms of U1 and R. So U5 is U1, which we don't know, times R, which we don't know, to the power of n minus 1. So this is 3. Seventh term is U1 times R to the power of 6. So this is 0.75. I have again two equations with two unknowns, U1 and R. However, I cannot use the linear solve app in my GDC, which I used in the previous question, because in this case, the two equations are not linear. See, I have R to the power of 4, R to the power of 6. I have U1 multiplied by R, so they are not linear. But to solve, I can do a small trick. Because everything in the left-hand side is multiplied, I will divide the left-hand side. So I start with the bigger one on the top. So U1 R to the power of 6 divided by U1 R to the power of 4 will be then 0.75 divided by 3. Why have I done that? I just noticed that if I do that, U1 will cancel, and R to the power of 6 over R to the power of 4 will give me R squared. So R squared is 0.25. Therefore, R is square root of 0.25, which is 0.5. So now knowing R, I can go back into one of the equations and replace, and I will have u1 times r to the power of 4 is 3. Therefore, u1 is 3 divided by 0.5 to the power of 4, which gives me 48. If you have time, you can check your answer. So we said that the first term is 48, then the ratio is 0.5. So the second term will be 48 times 0.5, so it's 48 divided by 2, which is 24. The next term will be 12, the next term will be 6, then it will be 3, then it will be 1.5, then it will be 0.75, and so on. So first, second, third, fourth, fifth term is 3, correct? Fifth, sixth, seventh term is 0.75. Find the number of terms in the geometric sequence. So again, I have the geometric sequence. What do I see here? I know the first term. Of course, I can find ratio, because ratio is between 0.75 and 0.25, so my ratio is 3. So I need to see how many terms are there until the term 44286.75. So how many terms I have until there? Well, this is the nth term. I don't know how big is n, but I can find looking at this formula. So un, which is 44286.75, is u1 times r, and r we said is 3 to the power of n. So here I have an equation, and I'm going to use n solve to find n. Here is my answer after putting this equation into n solve into my GDC. So I have 11 terms. In the case I'll get a decimal here, like 10.5, a decimal and not a whole number, either the question is wrong and this term is not part of the sequence, or my working is wrong, because I'm asked about the number of terms, so I should get a whole number. This is an interesting question, because you sense that it's a sequence, but they don't tell you which kind of sequence it is. So when a ball is dropped on a flat floor, it bounces to 65% of the weight from which it was dropped. The ball is dropped from 80 centimeters. So I drop the ball from 80 centimeters. Let's say then that U1 is 80. And my answer all my answers are in centimeters. It drops and then it bounces back at 65% of its height. Of course, the bouncing and dropping happens on the vertical, but I just picture it like this so that I can see better. So U2 will be 80 times 0.65, which is 65% of the first bounce. The third bounce will be 65% of the second bounce. So it will be 80 times 0.65 squared, and see how the geometric sequence is formed. On the fifth bounce, actually that's the first bounce, that's the second bounce, so the fifth bounce will be U6. See how the index is one bigger. Will be 80 times 0.65 to the power of 5, which will give me 9.28 centimeters to 3 significant figures. Please pause to read the question, and then let's see how we use GDC. So under Finance Solver, I'm starting to add my numbers. So a man invests, it's for 20 years, so n is 20, at 12% per year, 500, so the present value is actually negative 500, you'll see later, with one payment per year, so it's compounded annually. I need to find the future value, which is 4,823. Then I figure out that actually my present value is negative because I invest the money in the bank. But whenever I press negative 500 here, the future value will be positive, of course, because I will have this money. So my answer will be $4,820 to three significant figures. I tend to give my answers to three significant figures. Okay, let's understand this question. Mary borrows 7,500, so she has this money, but she needs now to pay them back at 12.5% per annum monthly, reducible over a period of 7 years. So she pays monthly part of the money back, such that at the end of the 7 years she will have paid all the money that she borrowed. Find the amount of each monthly installment, how much she needs to pay every month. So every month she will pay part of this money, but also for the rest of the money interest will be accounted. So that's quite a complex model. That's why the GTC will help us to solve it. Okay, so let's see what happens. Finance solver. I have the present value is 7,500 positive. I have them 12.5% per year. So 12 months times 7 years is 84 months, or 84 periods. The future value is 0. I need to pay all that what I borrowed back, 12 payments per year, so that's compounded 12 times. And now I need to find my payments per month. So if I press enter here, I find that I will need to pay $134 per month. How much do I actually pay? Is 134.4, let me be more accurate, times 84, because it's 84 times I pay. That's what I actually pay. So if I take away the 7,500, I find how much is the interest that I pay. So I've done that here. And the interest paid is 3,789.6.